Okay, so yes, lessons in humility, which is a very important thing for deploying robots. And like Simon sort of laid out at the start, really this talk, I'm not going to be particularly technical. I'm going to talk about the things which are actually more challenging often than the technical parts about deploying in the field. I work in the nuclear field. So for me, why I want to develop robotic and autonomous systems for the sector is it's about keeping people safe. In nuclear, whether it's a nuclear power plant or a nuclear storage facility, or in the cases where I've done most field work, a nuclear disaster zone, it's better to try and keep the human beings away from the radiation, because ultimately if you get exposed to large amounts of radiation in a short period of time, it can make you sick, or it can even give you cancer. And if it's really, really high levels of radiation, as per the Chernobyl disaster, it kills people. So robots can obviously take much more radiation than a human being. And so it's logical to develop the robot to go into the high radiation environment instead of the person. It's as simple as that. But there's tangential benefits in that, you know, if you've got robot systems which are performing surveys on a daily basis, they can be working potentially 24/7, whereas a human being can't. And so there's a productivity gain potentially, which actually is probably one of the biggest reasons why the nuclear industry costs as much as it does in the West, is the cost of people and the cost of the fact that things happen slowly. So if robots can speed that up, then that's a benefit for actually the cost of our electricity in the UK and America and other countries that are similar as well. So that's the sort of rationale for why I'm working with robots and why I'm braving some of these difficult environments to try and deploy them, in fact. I should also plug as well a facility which has just gone officially live this last week, which is a national nuclear user facility for hot robotics, which involves University of Manchester, so Simon's group, my group, and Tom Richardson at the University of Bristol, and also the UKAEA's RACE facility and the National Nuclear Lab up in Cumbria. So it's a multi-site facility which has some amazing equipment. Notionally £7 million has been invested into it, and it's there specifically to enable people to do field robotic deployments, to provide the equipment for people to make these deployments. So please visit the website, have a look. There's a menagerie of amazing equipment that can be accessed by UK researchers and also overseas researchers with UK collaborators as well. So please do check that out. That will make Simon, myself and Tom very happy. So talking about sort of nuclear deployments, I'm going to talk mainly about Chernobyl, but I just wanted to highlight that I've worked in quite a lot of difficult places. I started actually by working with Fukushima. After the Fukushima disaster happened, I started working with the University of Kyoto and the Japan Atomic Energy Authority, was very quickly involved with deploying UAVs over the fallout zone to try and map the radiation, especially around towns, villages, nuclear waste storage sites. And also through that, working closely with Sellafield. In fact, it was my team that did the first ever UAV flights over any UK nuclear site. So that was a little bit of history. And at the same time, we were mapping the radiation so that we could tell what was in what building or where the spread was. And that's really what my development of robotic systems has been for, is mapping radiological hazard and other hazards. We've worked on landmines, for example, and that's taken me to places like Somaliland. That got me banned from the US for a bit, because it turns out they're on a list, and I should have probably thought about that a bit more before I went there. But these are some of the things that you learn from these deployments. So I've been to some of the radiologically the most dangerous places in the world and come back to tell my tale for you today. Where I've just been for the last 2 weeks, and in fact Simon and Tom were teasing me because I was on the radio on BBC last night, but I spent 2 weeks working in Chernobyl exclusion zone and in the power plant. And actually this is a picture inside Unit 3. This is what we call the pile cap. You can see lots of square lead blocks. That's the top of the reactor core. And everywhere you see a gap in the blocks, that's where you've got a lot of gamma shining up from what's left inside the reactor core there. Now, this reactor sits directly next to the one that blew up, literally the other side of the wall. And so there's some quite interesting radiation distribution in that room. And of course, it's not the kind of room where as a human being you want to hang around at all, but it's an ideal sort of place to be testing out your robotics kit, in fact. So I've spent a lot of time working in Chernobyl. I've been out there 5 times working with the power plant and in the exclusion zone. And typically what we've been doing, both in the air and on the ground, is deploying robotic systems to survey and characterize where radioactive material is. Now, of course, in the exclusion zone, you've got fallout from the immediate fallout from reactor which exploded and had a fire. And so dotted around different parts of the exclusion zone, you've got spent nuclear fuel out in the environment. It wouldn't be good to come across that as a human being. And most infamously, the red forest, which is the most contaminated bit of land on the planet. And it's too dangerous for a human being to go into the red forest, but it's very appropriate to use UAVs at maximum line of sight or just beyond line of sight to go and map, sort of 10 to 20 square kilometers at very high spatial resolution. And actually that data has been very useful for governments to provide a baseline because the area, because of climate change, has been having forest fires, and forest fires that happen in a radioactive forest release radioactivity, and that gets everyone upset. So having really good underpinning what we call source term data is really important for making models accurate so that we know the level of risk. But inside the reactor building, inside the new safe confinement, it's a bit like Russian dolls. You have Unit 4, then you have the sarcophagus, then you have the new safe confinement. They're all different levels of radioactivity and contamination. And of course, you can see Spot here on the right, who's got some makeshift socks on so that he doesn't pick up contamination on the bottom of his feet. And he's got an integrated radiation scanning system. And he can trundle around, go up close to the side of the sarcophagus and make 3-dimensional radiation maps, which was the purpose of what we were doing. And to show, importantly, that you could repeat that very, very easily. A lot of what we're doing with the power plant now is showing that we can use exactly repeatable patrol robotics that can assist with the decommissioning to show at the end of a shift if the radioactivity's changed because there's some contamination in an area that it wasn't before that could be dangerous if a worker came in on the ground, for example. So it's about developing sensor systems which are pretty good for the high levels of radiation, including scanning LiDAR systems. Developed a lot of this tech by for the Rooster system from the University of Oxford with Maurice Fallon, which is an amazing bit of kit. Integrating that with directional radiation sensors, integrating all of that onto different robotic platforms, but Spot's one of the ones that we've done it for, such that the robot can patrol around, and as it does, we can build up a very accurate digital twin of the facility with coincident radiation mapping as well, which is directional and tells us where the really nasty patches are that you wouldn't want to go as a human being. So just as a quick video, which I hope isn't too laggy when it plays, this is an example of sort of Rooster data that's as recorded. This is a Pelinsky, which is a high-level nuclear waste storage site, where the trace is being recorded inside. You can see that we're recording radiation data about 1 hertz with 4 detectors. They're all directional. And not only to go around the inside of the facility, but to also go outside the facility so that by registering the inside with the outside, we can get things like the thicknesses of the walls. And we can make a very accurate 3D model, not only for placing the radiation data inside of that, but for doing calculations for shielding to tell us how effective the shielding is of the walls of the facility, of the thickness of the overburden that's on top of the high level waste. And actually from some of these surveys, and unfortunately I'm not allowed to show you the radiation data, it showed that some of the radioactivity had escaped from the burial site and was around the outsides of the site, and then had to be relocated while we were there after we'd found it. But some of the most radioactive things I've ever seen in my life, which is a bit of an eye-opener, I have to say. So that's the sort of kind of tech that we're working with trying to develop. But obviously we're doing it in some pretty hazardous environments. And I'll just walk through some lessons of learning now that I've sort of set the scene for what we're doing. So lesson 1, hope for the best and prepare for the worst. And what I mean by that is I always go by the rule that you plan your mission. Let's say it's a 2-week mission to the Ukraine. And you plan out a lot of stuff, a lot of kit to take, a lot of experimental measurements to make. But I always base it on the fact that if I only achieve 40% of what I set out to, it's still a technical win. I in that 40%, there's enough for several papers, there's enough to keep whoever I'm working with happy in terms of the quality and the amount of data that they've got. And I've always found through gaining the scars of these deployments, but that sort of 40% target is where you should set your expectations. Obviously, hope that you can get everything working brilliantly and get 100% of what you set out for, but make sure that mentally you would be happy with the 40% and set your targets appropriately. And of course, if you're shipping out kit, and I guess when we go to Chernobyl, we're shipping out somewhere between, I don't know, it's around £250,000 worth of kit. So it's worth a lot. You need to get it insured. You need to make sure your insurances are correct for it. And you need to expect the kit to get broken at some point. Usually, from experience, where we've had most breakages is actually in the kit being shipped in the aeroplane, in the hold of the aeroplane, by the baggage handlers throwing the heavy sort of Zarges cases around, or the Peli cases around, even though they say fragile with lots of stickers on the outside. When you get to your location and you're allowed to shake down your kit, you find that you've got some amazing damage that you wouldn't think possible, even though you've heavily padded all of the insides of your cases and secured your kit, you will still get some damage. So the way around that is to make sure that you bring spares of almost everything if you can, you know, from spare batteries to motherboards to, we even take a 3D printer with us now that we set up in the hotel room, along with, you know, a soldering station and things like that. So we take a lot of kit, which means actually it's quite costly. So we need to make sure that we've got the money to be able to afford to take all of that kit, and that people are prepared to be able to do stuff in the field in terms of repairs and have the spares to be able to do that. But the other bit around that is also we're going to odd environments, you know, Somalia, Ukraine. You've also got to account for the fact that people might get sick. That could be the food or the water. But it could also be the fact that people are working long hours, it's really stressful, and that people will get migraines, or, you know, just need to have a sort of bed day, in fact. So you need to be able to account for that. You need to manage your team to make sure that everyone's operating well enough such that they don't get sick. And that's an important consideration, because if your people aren't able to work, then probably your robots aren't able to work either. So prepare for the best. But expect the worst, or vice versa. The next thing is around transport, and I think you might hear this from a number of the speakers, but please, I would recommend plan well in advance, because transport, either getting your kit out to the field location or moving it around in the field location, can be very difficult. So for example, in Ukraine, we're not allowed to drive. We have to go in a registered vehicle, and we have a special driver or fixer who I think probably also works for the government. So he's slightly spying on us at the same time, but he's very helpful, who is responsible for getting us safely to and from the locations where we deploy, and for making sure that stuff is packed sensibly. Sometimes we carry kit on our knee when we're in the really expensive, sensitive stuff that's otherwise going to get shaken around. So you have to sort of be flexible about how you do your transport. But the biggest issue is around paperwork and making sure you have it. Everything from international driver's licenses through to the documents that you would need in case any of your kit would count as a dangerous good. And this leads me to this picture of Spot, because obviously we've got sort of quite infamy for taking Spot out to the Chernobyl power plant. It's very easy to take Spot out. It's very difficult to take Spot's batteries out. And that's because the batteries are so large that they're problematic for air freight. Now, rules with different countries vary, which means it's incredibly challenging. And it's been very, very challenging for us to get batteries out to the Ukraine on this last trip. And that's because authorities like in Germany have really tightened up on battery security. And we struggled. We didn't get Spot working until literally the last day, because our batteries that we were shipping in advance of us flying out were held up in Germany because they were too large on a sort of technical basis. Even though they were fully discharged, in the eyes of the German authorities, they still had too much charge in them, and we couldn't discharge them further because it would break the battery, so we could never use it or recharge it again. Those batteries individually cost $10,000. So we ended up with a situation where we couldn't get our batteries from the UK, so we tried Boston Dynamics to get sets of batteries out from the US, and again they hit the same issue. I think the batteries went from the US to Germany, back to the US, back to Germany, and finally got to Ukraine via DHL. But it was all because the capacity of these batteries is so large that they are perceived as being a really, substantial risk for putting them in an aeroplane. So we've learned that in future, for all large batteries, where possible, we will use land freight. We will send them overground, either driving them ourselves or sending them with an overground courier to make sure that they can get to locations successfully. But batteries has been a major issue for us. Lesson 3, be prepared to strip down. And that's specifically if you're working in Chernobyl, but also other nuclear plants, because you have to, at short notice, strip into PPE. And that's usually in front of your colleagues and other people who you don't know, where you literally have to strip naked with no warning whatsoever. So I guess in terms of this lesson, if you're going to be prepared to strip, make sure you've got good underwear every day that you're doing your field work, because you don't want to be caught out with your old Christmas pants on or something like that. But trust me, that happened to one of our team. But of course, in reality, when you're working in these dangerous locations, and you do need to take the robot close enough to where it needs to go to deploy it, that you need to make sure you've got personal protective equipment. And so, that's something that then can make deployments challenging, because if you're trying to control a robot and you're using a laptop for connection and you're wearing 2 pairs of nitrile gloves, then your dexterity is compromised. If you're trying to swap over a motherboard or something because you've just had a breakage and you're trying to do that wearing lots of PPE, it's not so easy. So PPE complicates things quite significantly. So do bear that in mind. Next lesson is to ensure you have all the right permissions. I've been arrested in the Ukraine. I was arrested in this last trip by the security services on the last day. It was mainly because they wanted to see the equipment and take lots of photos and ask technical questions, probably for their own security files. But I was also, every single day in Fukushima, the first time we went, I was arrested on a daily basis with the rest of the team. And in various other countries as well. And it's not because I've done anything particularly wrong, it's just because the local law enforcement and security services were curious, or they wanted to check that we had the right paperwork. And of course, it's not much fun when people with guns pull guns on you and hands in the air kind of stuff. So, my advice is to make sure that not only do you have the correct paperwork, but actually one of the first things you do when you get to an area is you engage with the security services, whether that's the police or the Secret Service, and make sure they know you're there, and almost do a show and tell of your kit in advance of them turning up. My scariest experience was in Somalia, where I was staying in a secure compound. You can see a little photo of it here in Hargeisa, which is the capital city of Somaliland. And this is a pretty rough place. Around the country, you've got bits of old military infrastructure, which is degraded. You can see a picture of an old cruise missile on the right-hand side, just sitting around. But we got there, and I was to do a demonstration of a radiation mapping drone for the government. And that was to happen a day after we arrived. So when we arrived in this compound with, lots of razor wire and armed guards, and this is a photo that I took looking back on the compound, I needed to set up my drone. I needed to ensure it was well calibrated and to give it some test flights. And inside the compound, there wasn't much space. So I could get the drone switched on, do all the basic checks, do a little hop, but really I needed to get into open ground. And surrounding this compound was a wonderful open area, which I learned later was a deliberate open area as a killing ground for defense. And I asked the guy who was working with me if I could go outside. But what I didn't realize is that he didn't have the authority to say no to me. And I thought he was in charge of my security, and he was in charge of my safety, but he felt he couldn't say no to me. So when I said, I need to go outside and find my drone, he said, okay. And he went out and he brought someone with an AK-47. And I stayed outside for about an hour and a half, doing practice flights, doing grid surveys, testing. And what we noticed through that period of time is people around the edge of the big open area had started to turn up and take notice. And a car had come and approached and had asked where I was from, and then driven off again. And I didn't think anything of it because I'm a naive academic. But 5 minutes after that car had come through, an incredibly well-armed security detail rushed out of that gate that you can see in the picture, put my head on the ground and dragged me bodily back inside the compound. Someone else dragged in all the kit, and they shut all the doors, and they all prepared as if we were about to be shot. And that was because they'd been listening to the radio, and Al-Shabaab, who are a terrorist group in the area, they'd been listening in on, and they had thought that we were CIA, bringing drones to try and find their safe houses, and they were preparing a strike on us. And so I was left in a position where I felt it was my fault that I just brought the house down. And we were given a security briefing that said, this is what you do in the event that they manage to get inside the compound and shoot all of the guards. And so I spent an entire night waiting for this to happen, sitting on the edge of my bed in full field kit, because they did say, if there's a chance to get away, we'll get you into an armored vehicle and get you out of the compound. But it all happened, and thankfully that never happened. And the next day we were snatched to another safe house. But it all happened because I misunderstood who I needed permission from to make my deployment. And that was a lesson very, very hard to learn. I won't make that mistake again. A couple more lessons, and Simon, you're going to nudge me when I'm talking too long. Watch out for the wildlife, because it's not just humans, as per this sort of discussion from Oxford, that can be problematic for robots. It can also be the wildlife, whether it's the wild dogs of Chernobyl, who took a great interest in Spot, or it's something like the local fox. This is Simone, who lives in the fallout zone, who peed on one of our drones at one point, because we'd left the drone on the ground while we were going off to swap batteries. And I don't know what possessed the fox, but he decided that he wanted to pee on one of our little observation class drones, which didn't break it, but it made it smell pretty bad for the rest of the trip. So I, through my robotics field work, have encountered lots of different wildlife that's notionally probably radioactive. I guess snakes is the worst. I seem to be a magnet for snakes. But, that's part of being aware of your surroundings when you deploy, is not just the human sort of risk, but it's also the risk posed by wildlife. It's had some very weird experiences being chased by radioactive wild boar through forests in Fukushima, for example. In association with going and working in nuclear fallout zones, of course, you've got to be prepared for basic living. And you can imagine actually working in Somaliland was very basic as well. So expect to lose weight. Don't expect to have all of the mod cons. And actually, what is most difficult is often going for periods of time without any power. So we always have our own generator that so for example, in Ukraine, our driver looks after a generator we've bought, and whenever we go into the field, he has a generator ready for us so that we're able to charge laptops, batteries, anything that we need on the fly whilst we're in the field. But also things like really, really poor Wi-Fi or no Wi-Fi whatsoever is very limiting in case you need to connect back to home in order to, download some script that you've got to bring with you, or download manuals or anything like that. You've got to make sure that you're well prepared, so you're self-contained. If you're out of comms, you're out of comms, but you still need to be able to function. And it also means it's difficult if you're away for several weeks, you can't talk to your family. So whilst I was in Ukraine, the comms were so bad, I didn't properly speak to my wife and kids more than once. So, you've got to also make your families ready for the fact that you're going to be away and potentially completely out of comms for the whole time. I'm nearly done. I think this is the last one is about being prepared to deploy at short notice and not necessarily by your own team. And I think this goes back to sort of a little bit of what Nick was leaning towards as well. certainly what we've learned is that we spend lots of time planning our itinerary down to what we're going to do in each half day of a trip. And it's really, really detailed. And pretty much as soon as we arrive, our plans get shredded by, the local authorities who are giving us accesses, and they're telling us that actually we're going to go to this site on Monday and a different site on Tuesday. And then when you're there, they're notorious for saying, right, well, we did say you could have 2 hours here, but now we've only got 15 minutes. So you better get on with deploying your robots. So the best way to mitigate that sort of situation is, first of all, if you are really, really well practiced as a team, then you can be quick to deploy. And what I mean by that is, before you go on any big field deployments, make sure you've spent necessary weeks practicing and doing practice deployments at base, whether that's in the car park outside your lab or somewhere nearby, but get lots of practice as a full team, such that when someone does say to you, right, you've got a quarter of the time that we said we were budgeting for, you go now, that you really can go now. But also, if you're the trip leader, you've got to be prepared to fight your own corner. And if they're saying, well, now you've only got 15 minutes, you have to be prepared to stand up and say, no, we agreed 2 hours. We need 2 hours. So, and if you want decent data, you've got to give us the time to record it. So this is something that's really challenging in the field, is actually managing the fact that it's all very fluid, and you need to constantly be engaging with the people who are giving you accesses and potentially taking away your accesses, to make sure they're aware of how long things take, and how much time you need to set things up and pack things down as well. So in summary, my rules of thumb that I've learned the hard way: practice regularly. Practice makes all of the difference. If you've done lots of practice, then the actual field deployments will go well. And we're going to start implementing a 1 month out practice rule, that if you can't get your kit working exactly as you want it 1 month before you then make the real deployment, then that kit's not going to go. That's where we've got to. It sounds probably quite draconian, but it avoids having big issues in the field. And big issues in the field for me means lots of stress in the field, not just for me, but the whole team. Sort out your paperwork early, because it does take time, especially things like carnets for import and export. You don't want people taking away your kit as you try to leave the country and saying, thanks very much, we'll keep that. You don't have the right paperwork. So make sure that you've got a really, really keen eye on the paperwork and ensuring everything's correct, and start it early. Like I said, don't ship out kit that's not working yet. Use the cutoff that I'm sort of suggesting. It doesn't have to be a month, but something like that. Prove to me that the kit's fully working, and then I'll let you deploy type approach. And accept that sometimes it won't be you deploying kit. We certainly have had this a lot in Chernobyl. It might be someone from the plant who would have the equivalent of maybe a BTEC. So make sure a non-specialist can deploy your kit if at all possible. And mainly that's around the human interface, the GUI, or whatever you're going to set up in terms of the software. Make it very intuitive and easy to use. We had a couple of disasters in that respect on the last trip, where we had some plant operatives deploy kit for us and wonderfully set it up in the right location, and then shut the whole thing off by pressing a button they weren't supposed to press. And then, no data at all gets recorded. Spares and more spares, don't forget that. And of course, record as much as you can, because documented footage is both good for papers, but it's also good for the sort of PR with the people that are hosting you, so that they can see what you've been doing and show that to other people in their organization or higher up in government as well. And that's all part of keeping your hosts enthused about what you're doing. You've got to keep them on side. And the last thing is, if you're in extended deployments, do give your team a break, because although robots might be able to go 24/7, human beings can't. And if you don't have your team happy and healthy, and it goes back to what Nick was saying, is the team is all important. If you don't have a happy, healthy, productive team, then the deployments just simply aren't going to work so well. So there we go. I hope you will learn from some of the scars that I've managed to acquire, such that you don't make the same mistakes that necessarily I did at the time.
Thank you so much, Tom. That was a brilliant talk. So many things you can relate to, me personally as well. And you mentioned the magic word carnets.
Yes.
That deserves a talk of its own. And in some cases, look, in the interest of time, what we'll do is we'll move the questions over to Slack. Tom will be around on Slack to answer the questions, and we will also have breakout sessions that Tom will be participating. So I'm pretty sure there are lots of questions. Please ask them during the breakout session or on Slack.